Okay, so this is the second video about probability. The one before this was about sample spaces and listing out all the possible outcomes. And then this one's going to be about simple events and how we use those simple events, the probability of something happening, to predict and compare. So those are the main verbs of this lesson, if you will. So for simple events, it's really simple. You would roll the dice once. That's a simple event. It's one event. Okay? If I had a cup that has yellow game piece, maybe it has a red game piece and a blue, and I draw one piece out and I just do one draw, that would be a simple event. So simple event is just one thing happening, which is what this video is going to focus on. Okay? So we talked in class about how we can kind of organize our thoughts whenever we have a probability question, and how we're really, really successful with it. So we are going to stick with that format. So if you get a probability question, you really want to organize it. First off, by drawing the picture. And when I say picture, you're really drawing all the possible outcomes. So I'm going to use rolling a die as an example. You'll hear it called a fair-sided cube. It's the same thing. Okay? So I'm going to list out the sample space, that's my picture, of all the possible outcomes, everything that can happen when I roll this dice. So I can roll a 1, 2, 3, 4, 5, or 6, and that will allow me all the possible outcomes. I can never roll a 7 with this dice. I can never roll a 0 or anything else. It's just these numbers. Okay? So then we talked about, okay, well, I want to know the probability of, and you read the question. I'm going to do 3 because that's my favorite number. So probability of rolling a 3. And we use this notation to kind of say, hey, probability of rolling a 3. All right? So then for every event, we're going to represent the probability of this event happening, probability of rolling a 3, as a fraction. So you have your favorable outcomes over all the total possible outcomes. And that's how you set up probability all the time. So I look at my picture. I'm going to circle my favorable outcomes. There's 1 out of all these that's favorable. I just want probability of 3. There's 1 out of 6. So that's the probability of rolling a 3. Okay? So, as another example, we'll go back to where we were drawing something out of this cup. Okay? So to draw my picture, all the things that can happen, I have a red, a blue, and a yellow. So red, blue, yellow. That is my sample space. All the things that can happen if I were to reach in here and draw one of these pieces is I could draw a red, or a blue, or a yellow. So I want the probability of drawing red. Let's just say red. I'm just picking that. So I'm going to reach in here, draw a red. I know that there's 1 that is favorable outcome. If I draw that red, I'm happy. If I draw the blue, I'm not. Yellow, I'm not. So there's only 1 favorable outcome out of 3. Okay? So I can convert that to a decimal and a percent. Okay, but we're going to stick with the fractions. I know that y'all can convert those. That is something that you'd want to try to practice. Because sometimes questions, it'll only give you answer choices in decimal form. You have to know what that is as a decimal. But let's just look at these fractions for a sec. If you remember back to the 2 verbs I said we're going to focus on, they are comparing and predicting. So we're going to compare these. We're going to start with that one first. Okay? So let's pretend you're given a choice to either play this game with the dice or this game where you drew a game piece. Okay? You win $1 million if you choose the dice and roll a 3. Or you win $1 million if, let's say, you go with this game, you have to choose the red. Which game would you play? Hopefully, you are saying that you would do where you would choose the game piece, because that is a higher probability. It's higher likelihood that you win than out of this one. For this one, 1 out of 3 will give you the win. On this one, only 1 out of 6 will give you the win. Okay? We had these number lines taped to our desk when we were talking about this. Zoom out so you can see it as a reminder. 0 means it was impossible, and always means it is always possible. Half, if it's right at half, it means it's equally likely to win or not. You're never going to have a probability more than 100%. You're never going to have a probability less than 0. Okay? It's impossible. You can't get less than impossible. Always, you can't get more than always. Okay? So if I go back to our games, the probability of winning when you rolled this one was 1 out of 6. So 1/6 would be somewhere down here. It's definitely unlikely. It's possible, but it's unlikely. Okay? When we go to our game pieces, it was 1 out of 3. And 1 out of 3 is going to be more up here. And these aren't in exact positions. But what you're going to find is that you're going to want to do 1 out of 3 has a higher likelihood. They're both unlikely, but this one is more likely. So you would rather play this game. So that's how you would compare with simple events. We can also predict. So I'm going to go back to the dice example because we're all pretty familiar with this game piece. It's used in a lot of games. Okay, the probability of rolling a 3, we already decided was 1 out of 6. Well, let's say that your little brother says you get to roll this dice 60 times. Okay, and he wants to know how many times you'll have it land on a 3. Well, you know 1 out of 6 times it will probably land on a 3 in theory. So remember, this was the total possible outcomes, and this was what we wanted, which in this case we wanted to roll a 3. That was our favorable outcome. So we can make a prediction. We use proportions in math when we want to make predictions. And we know I'm going to be rolling this, let's say we said our example was 60 times. So 60 total rolls. And how many would you expect to land on a 3? Okay, well, if I roll this 60 times, I'm going to definitely expect it to land on a 3 more than just once. Now, I'm not going to roll this 60 times for you. I know as much as you want to see this happen 60 times, I'm not going to do that. So there's 1 3. And guarantee it's probably going to land on 3 again. Mathematically, in theory, we can figure out, in theory, how many times we would roll a 3. We would simply solve a proportion. Okay, so this is like our unknown. You could do cross products, 1 times 60, and write all that out. Or you might remember this from last year. 6 times 10 we know is 60. So this one actually has a shortcut. If I multiply the bottom by 10, I multiply the top. I'm going to expect or predict 10 times. I'm going to expect it to land on a 3 10 times out of 60. So if you're ever making a prediction, you're going to be using the proportion to help you do that. Okay? I'll give you an example of what this might look like. Heather has a bag of 15 red, 11 orange, 9 yellow, 12 green, 6 blue, and 11 purple markers. How many times would you expect Heather to pick a red marker if she picked a marker 90 times? So you have to look at the simple event, the given ratio. I know that there's 15 red out of, and you would have to add all these up to find the total. So there's going to be 15 red. And we know the problem tells us there's 15 red, 11 orange, 9 yellow, 12 green, 6 blue, so you can see it, 6 blue, and 11 purple. So you would need to add those up to figure out how many total markers are in that bag. So 5, 6, 7, 8, 9, 10, 14, 15, 24, 2, 3, 4, 5, 6. Okay, so 64 total. And I believe that's correct, but we shall see. And then it says if she picked a marker 90 times. So this is your simple probability, your simple event. I have 15 red out of 64 total equals, and we want to know how many red out of 90 total. And so on this one, if you look at it, you really can't do just this rate of change. So you'd have to do cross products. You would do 15 times 90 equals 64 times x. Okay, simplify, isolate the variable, and find the answer. But the key to all this is your given ratio. It's your given probability. In our dice example, our given probability, we know for a fact, in theory, you would roll a 3 1 out of 6 times. So maybe you roll it 1,000,000 times. It would be x over 1,000,000. Okay, and so you can make predictions that way. And so that wraps up our video on simple probability, where you just had one event. And so our next video is going to be about compound probability.